This video will demonstrate how to determine a molecular formula given percent composition and a molecular weight. So let's take the given values of 30.72% carbon, 7.68% hydrogen, and the remaining percentage, 61.6%, is oxygen, with a molecular weight that's recorded as being around the value of 234 grams per mole. This is enough information to actually do the entire thing. So we assume 100 grams because that makes doing the math a lot easier and convert that into moles. So 30.72% of 100 grams is going to be 30.72 grams of carbon. And we can divide by 12 grams per mole, which is taken from the periodic chart. This gives us 2.56 moles of carbon. We do the same thing for the hydrogen and the oxygen. 7.68 grams of hydrogen divided by 1.01 grams per mole. And this gives us 7.6 moles of hydrogen. And finally for the oxygen, 61.6 grams of oxygen divided by 16 grams per mole will give us a value of 3.85 moles of oxygen. And so these three pieces of information form the basis of what we need to know for the next step. We have to figure out which of these moles is the smallest amount and then divide everything by that to get our mole ratios. So 2.56 gives us the smallest amount, so our ratio then 2.56 for carbon, 7.68 for hydrogen versus 3.85 for our oxygen. So if we divide through by that, what we find is that we have a ratio of 1 carbon to 2.97 for our hydrogen and 1.5 for our oxygen. So this ratio then gives us the basis for finding an empirical formula. You'll note that these are not all whole numbers, but we can round off that 2.97 on the hydrogen here to a value of 3. And so when we write that out, we have to find something to multiply that weird looking empirical formula where we have 1 carbon, 3 hydrogens, and 1.5 for oxygen. So we determined that you can multiply this whole thing by 2. Multiplying by 2 gives us an empirical formula of C2H6O3. So that empirical formula then can be used for the next step. We have to determine an empirical weight to compare against the molecular weight which we were given. So we have 234 grams per mole, and we're going to compare that against something times the empirical weight. Should give us our answer. And so an empirical weight for this is 78 grams per mole. And so the value that we need in order to make this work is 3. And so now we can use that 3 to scale up the empirical formula, C2H6O3. We're going to multiply that by that scaling factor of 3. And this will give us our molecular formula of C6H18O9. And so you can determine for yourself that a molecule with this formula will have a molecular weight that's around 234 grams per mole. And this concludes how you would use percent composition and molecular weight information to determine a molecular formula.